Okay. Now the fourth case is we should place at focal length, center of curvature, focal length, center of curvature. We should keep the fourth case is the object is placing at the center of curvature. Now we are keeping the object at the center of curvature. First one, draw a parallel line. Draw a parallel line. Then what will happen? It will pass to the focal point. Then the second point, up through the optical center. Definitely it should touch the tip of the object and pass through the optical center. Okay. Okay. Now it will look like this, and here it will pass without any refraction. And then what will happen? It will meet however, when you draw your diagram according to the scale, the image will form like this. Okay, at the image will form at the center of the curvature itself. Here, object is placed at the center of curvature. Here, image also formed at the center of curvature. Okay, then when we are discussing the characters of the object, characters of the image, what you can say? This is formed due to the true rays. Real rays pass by. Therefore, this image is a real image. And what about the upright and the invertedness? Here, the image is the upside down of the object, so that the image is inverted. And then, what about the size? When you draw in your paper, in your book or in your paper, you will observe that this object is same as the size of the object. Image is of the same size of the object. Okay, same size as the object. And then what about the place the image formed? You kept the object at the center of the curvature. You kept the object at the center of the curvature. Then where did the image form? Image also formed at the center of curvature. If you place the object at the center of curvature of one side of the lens, the image will form at the other side of the center of the curvature of the other side. So I will give some small time for you to draw this ray diagram and write the characters of the image forming. After you draw it, please send. If you didn't get the if the image you get is not at the same size as the object, please send me your send me a photograph of the ray diagram you drew. I mean WhatsApp me. Then I will see what mistake you have done in that ray diagram. Okay. Still others draw. I will explain this what we have done to our newcomer, Nitesh. Okay. Nitesh, what we did now is we position the object at the center of the curvature and drew a ray diagram. Okay, so now the object is at the center of the curvature. Then we know that when we are when we are drawing the ray diagram, first we draw a ray parallel to the principal axis. So we drew the ray parallel to the principal axis. Then when a ray travel parallel to the principal axis, it will refract passing across the focal length, focal point. Then the second thing when we are doing when we are drawing the ray diagram, what we do as the second case is we are passing a ray through the optical center. Then when a ray of light is passing through the optical center, it will pass without any refraction. Okay, so here we have drawn the ray passing through the optical center so that it will pass without any refraction. So that is the second point. So these two rays will meet at some point. Definitely, if you draw your ray diagram to a scale, definitely it will form at the image will form at the center of curvature. Okay, that means but it is an inverted image. Inverted image, that means upside down of the object. Okay, so that the formed image is an inverted image and same size as the object. If you draw it to a scale, you will observe that the image is same size as the object and it is real because it was formed due to the passing of real rays. Okay, not virtual rays. If the object formed due to the extended ray, that is called as a virtual image. But here this is formed due to the real refracted rays. Therefore, this is a real image, inverted and same size, and it is positioned at the center of curvature. If we kept the object at the center of curvature, image will form at the center of curvature itself. Okay. Now, then we are moving to the fifth point. Okay. Yes. Okay. Then our fifth part is that just like this. Okay. Then the fifth part is here. Here is our principal axis. Here is the lens. Here we can draw the optical center. Here, this is the optical center of the lens. Here, this is the focal length. Here, this is the center of curvature. Here, this is the focal length. Here, this is the center of curvature. So, now the object is placed beyond the center of curvature. That means away from the center of curvature. Now, as usual, our first step is to draw a parallel ray that is passing across the draw a parallel ray which is passing parallel to the principal axis. Then what will happen? But it should touch the tip of the object. Okay, passing parallel. What will happen? If a ray pass parallel, it should refract and pass through the focal point. Then what should happen? Then the second one, passing through the optical center. A ray, second step is drawing a ray that is passing through the optical center. Here. A ray passing through the optical center. Here I am drawing the ray, but it should also touch the tip of the object. Then you can see that the rays will meet at somewhere else here, like here. Okay, the object will form between center of curvature and the focal point. Okay, you place the object away from the center of curvature so that object object formed between the focal length and the center of curvature. Okay, this is the last part, and then we'll go to the comparison. Now I have to describe that the characters of that image. Here, what about the characters of this image formed? This is real or virtual. This is formed due to true rays, truly refracted rays. So that this image is really real image. This is a real image. So what about the inverted or upright? Definitely this is inverted, because this is the image formed is upside down of the object. Then what about the size? What do you think? What do you think about the size? Smaller or larger? If you draw it correctly according to the scale, definitely that will be smaller. Okay, now I am drawing without a scale now. So if you draw it according to a correct scale, definitely that the object size should be smaller than the image size should be smaller than the object size. Okay, you draw, and after this point you send me all the ray diagrams you have drawn. Okay, inverted, real, smaller than the object. Then what about the position? We place the object away from the center of curvature, but the image formed between the center of the curvature and the focal length. Okay. Now I'm waiting till you WhatsApp me the ray diagrams you have drawn. Okay. කියන්නේ දැන් ඔයගොල්ලන් image එක අපේ data diagram එක අඳිනකොට මේ මම scale එකකට මට අඳින්න බෑනේ white board එකේ. scale එකකට ඔයගොල්ලන් ඇඳ හරියටම ඔයගොල්ලන්ට object එකට වැඩිය smaller size තියෙන image එකක් form වෙනවා. හරිද? දැන් ඒකයි මම කිව්වේ ඔයගොල්ලන්ට WhatsApp කරන්න කියලා මම මේක ඇඳපු එක. දැන් මට ආවේ larger image එකක් නේ. ඒ මම raise ඇඳපු නැති නිසා දැන් මම raise එක චුට්ටක් adjust කරපු ගමන් ඊට වැඩිය ටිකක් පොඩි එකක් ආවා. මේ image එකක්. දැන් ray diagram එකක් consider කරනකොට මේ focal length එකටම මේ focal length එකත් equal වෙනවා. මේ center of curvature එකට මේ center of curvature එකත් equal වෙනවා. එහෙම නැත්නම් ඔයගලන්ගේ ray diagram එක වැරදෙනවා. exam එකේදී ලකුණු දෙන්නේ නැහැ. දැන් exam එකේදී scale එකක් තියන්නේ ඒගොල්ලෝ අපිට ruler එකක් තියෙනවනේ. එතකොට ඒ විදිහට අඳින්න ඕනේ. Actually, we have to discuss. And Stalin asked whether what happened when the object is kept at infinity. We have to discuss it in our syllabus, no? So I'll discuss after this when the object is kept at infinity. Okay, when the object is kept at infinity, that is our sixth case. Okay, when the object is kept at infinity, I will draw the ray diagram. Okay, that means you have done. So our last case under refraction, that is okay. The last case is if the object is kept at infinity. Here, this is the focal point. Here's the center of curvature. Here's the focal point. Here's the center of curvature. Now, infinity means what? Greater than 4f distance. So, if this is focal length, 1, 2, 3, 4. This 4f will be at a place like this. 4f. That means away from this point, the object is at infinity. Okay. So that we think that now the object is at infinity. Now, first thing is drawing a parallel ray. Okay, what will happen? It will pass through the focal point. Okay, now the second thing is optical center and the passing through the ray passing through the optical center, touching this one. I mean touching the tip of the object. So how can I am not good at drawing straight lines. That's the case here. Yeah. Here. Okay. Now like this. Okay. Actually, this should be also wrong. Because when you draw it to a correct scale, the object should form. It will definitely come to a point like this. Okay. When you draw it like this, it will definitely should come to a point like this. That means the image should lie at the focal point. Focal point. Okay. That means it will be a very small object like this, a real image and inverted image. Real, you can see inverted, very small at the focal point. At the focal point. That means image will form at the focal point. You can see the focal point here. So that image will appear like this. These two will meet like this, and then after you draw this ray diagram also, you have to send me a photo for sure because I have to check it. So we can correct the mistakes. And so what you have to remember, infinity means if the object is placed at a distance greater than the 4f, 4 times of the focal length. That is exactly very correct, because you haven't you have assumed that the image is very large and at infinity. I will send it to the group. This one is also correct. Here we can get a very much small image. As it here we cannot actually see the size of the image because it is very small. But this, I sent one of the student have drawn this diagram. See it. I sent it to the group. He have assumed that the object is at infinity and he have drawn. This one is correct. This one is correct. Here we can see that the object is at infinity because it is greater than the 4f distance. Here we can see the object. This is the least distance where infinity can lie. Okay. Then the small, we have seen that the object is very small. No? So I'm going to erase this one because, okay, now that Shannon have drawn it like this. He have assumed that Nitesh, you have done a mistake. That is, I said you always that when a ray is passing, it should touch the tip of the object. Okay, you have started the object ray from at the middle part of the object. Okay, so that the ray should pass at the tip of the object. Okay, if not, the ray diagram will get wrong, because you definitely, according to the ray diagram you have drawn, the object image size is very smaller, very much smaller than what you got. Okay. Okay, I will send you the corrected one. The rays should pass from here and then it will pass through this likewise. Okay, it should be corrected. Both the rays should pass from the tip of the object. It should pass from the tip of the object. Shelly, I'm waiting for your one. Got it. Wait. Yes, your one is correct. According to the Shelly's diagram, we can't see actually size of image. Very small. Okay, I'll send that even to the group. Very small, because it is the least distance where the infinity point can lie. Okay, we drew the infinity point near the 4f now, away from 4f now. Then now we are going to discuss how Nitesh, how Shalon drew it, drew the ray diagram, drew his ray diagram, focal length, center of curvature, focal length and center of curvature. Nitesh, send me the corrected one. You have done it. Yes, you were not at the beginning. No, sometimes you may have confused with that point. Okay. Okay. Now, what Sharon have drawn is, he have assumed that the image is somewhere like this. That means it is at infinity. So he have drawn that a ray is coming from the infinity passing the focal length. Ray is coming from the infinity across the focal length. Here, across the focal length, then it will pass parallel to the principal axis, the first ray. Okay, then the object is passing through the, he have drawn the ray diagram from 3 to 1 likewise. Okay, he have drawn a ray that is passing from the focal length, and then it will pass parallel to the principal axis. Then the second ray, what will happen? The across the optical center, because object is at infinity, no? So the object can be anywhere else, here, here, here. It can be anywhere else, not in the board, but not in the board and not in your book. Okay, it is somewhere else, infinitely long distance. So passing from the infinity across the optical center, so that the two lines join at here. The two lines joined at here. Now you can determine the size of the object. But the case is, when compared to the size of the image, it is very, very small. Now I am telling that according to this ray diagram, this object must be larger than 5 meters or 6 meters. Very large. Okay, because these two will meet at a point where it is at a point where 5 meters, 6 meters or 10 meters height. That object may have about 10-meter height, because these two will meet at somewhere like this. Okay, if that means the object is at very, 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 very far away point. Okay, even we can draw the ray diagram like this one, and the simplest way to draw is keeping the object. If you want to see, if you want to draw the infinity, that means infinity, the ray diagram for the infinity, the ray diagram for the infinity, the ray diagram for the object at infinity, what you have to do is, and if you want to see the object and the image formed at the ray diagram at a same paper, on the same paper, you want to see both the object at infinity and the image form when the object is at placed at infinity, you have to take the object, assume that the object is at a distance greater than the fold, and even you can assume that object is not at the paper, not on the paper, object is not on the paper, it is very, very far away from the paper, and then you can draw this the ray diagram like this. Here you have, first you have to draw, because we can't draw parallel line, because object height is very, very, very high, very, very, very high. No? So we have to draw the parallel line which is touching the tip. We can't draw the tip of the object in the paper. We can't draw the tip of the object on the paper. So we can't draw the parallel line. So definitely you have to draw the ray diagram by using these two principles. Did all got it? Those two, all the two ray diagrams are correct regarding to the point when the object is placed at infinity. Okay. Okay. Did everyone get all the points? Is everything clear for you all? Draw this ray diagram also. So only 5 minutes. We have to explain this ray diagram because Nitish came, lost the connection and came again. So I will explain as soon as possible. That means here what I have done is, here this is also a ray diagram which can be drawn to when the object is placed at the infinity. Here, last time we assumed that we can see the object at infinity and it is greater than. We know that infinity is at 4f now. So that away from the 4f it will be at, the image will definitely, the object will be surely at infinity. Okay, now here what we guess is that the image is very far away from the object, and the object is very far away from the lens, and it is very much larger than the very much larger that we can't draw it in the paper. Okay, on your book you can't draw it because the object is larger than your book. Okay, that's why we have drawn the rays like this. Okay, so that here we can't draw parallel lines. Why is that? We can't draw parallel lines because object tip is not at the paper, not on your book. Or we can't draw the object tip on your book, so that we can't draw parallel lines. So that definitely we have to draw these two kinds of rays. Then first one is through the optical center. Then the ray is coming from, we assume that the object is very high enough, so that ray is coming from the optical center. It will pass without any refraction. Here the object is passing across the focal point the second time. Then it will pass parallel to the principal axis. Then these two lines will meet at a point like this. Definitely it will be at the focal point. Then the image is inverted. Now you can see the image. The size of the image, this is comparatively small, very smaller than the object, because object must be definitely will be definitely higher than taller, like 10 meters or 5 meters likewise. When compared to the object size, this is very small, because you can, the object is greater than your page size, the page of your book. Okay, that's why we couldn't draw a parallel line. Okay, so here's this is also, this ray diagram is also, you can draw this diagram also for the ray diagram, as the ray diagram when the object is placed at infinity. Okay, then ayo, he left again, no? Okay, then this is the end of the lesson, but we have to discuss some small parts, that is under total internal refraction. Likewise, I will cover this thing within, if the time was not enough, we will call the meeting for another 10 minutes or 20 minutes, 10 minutes likewise. Okay, so here it goes like this. Now yesterday, no, I will give you the summary that we discussed. Here the convex lens is there, here focal length, here center of curvature. Okay, likewise, when you place the first situation, when you place the object between, I will name this as the O, optical center. When you place the object at the optical center and the focal length, focal point, what happened? The image was virtual. See, turn to your ray diagram. Image was virtual, upright,